Okay, we're going to work a couple examples here of polynomial inequalities as well as rational inequalities. I want to start out by opening up a website that I think is a very, very good website to use, both for calculus, pre-calculus, which really we show here as algebra. And if you'll notice that his class notes broken up into algebra and calculus 1 and 2 and 3. But the main thing is if we look at the notes, practice problem, and assignment problems, this is a very good website to use. So I want to encourage it. I will drag it open. You see the URL there, and I'll put that on the website as well. So let me go ahead and minimize this. So you'll have that there at the top, and let's go on with our problem. So we're going to grab a couple problems. The first one I'm going to do is problem 14. And problem 14 is going to be let's see if we can find our way here. It's going to be x squared. X squared is less than or equal to 16. Now our strategy here is always to bring everything to one side and put 0 on one of the two sides. In this one, it makes the most sense, I think, to write x squared minus 16 is less than or equal to 0. So the first step is everything to one side. Okay, 0 on the other. So 1, put 0, 0 on one side. Let's try on one side. Okay, the second step is put the expression in ZFF. Okay, we want to use zero factored form wherever possible. That's the idea. So whatever you have, you want to look at the characteristics of this curve going on top of or on the bottom of the x-axis. In this case, we could easily write it as x minus 4 times x plus 4 is going to be less than or equal to 0. So after we do that, we realize that anytime this left side is going to be a negative number, this is going to be a valid statement, or if either one of these two factors is equal to 0, this is a true statement. So then what we're going to do then is we're going to go and build a number line. Okay, so let's build a number line. Now our number line will be then delineated with what are called key values. In this case, here's our number line. And for what we're working with here, our key values are going to be the zeros. So one key value is going to be negative 4, and the other key value will be 4 for this problem. So let's just put KV for key values. Now, what we're going to do next is I use the word delineate a lot. Delineate is to separate. And when we separate, we're going to separate this number line into regions. Okay, we're going to separate everything to the left of negative 4, everything between 4 and negative 4, and everything beyond negative 4. So we're going to make what we call test values. Now I like to use a discrete value for the test value, and I have favorites. And I just like to use negative 10. And if I can pick an easy number between negative 4 and 4, which is 0, I will do that. And then I will pick something after 4. If I have a choice, I will pick 10. So from now on, we're going to evaluate this left side of this expression. And we're going to do it by jouping. We're going to joupe these two factors. Notice we have the factor x minus 4, and we have the factor x plus 4. And I call this my sign analysis, okay? I'm just going to use signs and zero factors. Or I'm going to evaluate what the sign of this thing is if it's not in factored form, just by plugging that negative 10 into it and determine. So I'm going to joupe my sign analysis if I have zero factored form throughout my problem. And I want to evaluate that. So now I've established my joupes. My jupes are now, if I plug in negative 10 into this x here, I get negative 10 minus 4, negative 14. That is a negative number. And then negative 10 plus 4 is a negative 6. That's a negative number. We know by our multiplication rules with positives and negatives, two negatives make a positive. So then we're going to go ahead and make what's called a conclusion statement. Okay, is this positive number less than or equal to 0? And we notice that it is not. Positives are not, so we put no. Okay, we just put no. And we do not include these numbers. Now, since this was an equal sign with the inequality, I'm going to fill this dot in here. And I really like to do that in the beginning. Okay, so next video, maybe I'll remember to do that in the beginning. So we evaluate that equal sign. Those are going to be answers that are A-OK. So let's move on. Let's put 0 into these two factors. 0 minus 4 is a negative number. 0 plus 4 is a positive number. Negative times a positive is a negative. So my conclusion is yes. This is great. And I get very excited when I get yeses. So therefore, I'm going to go ahead and scribble my solution set. And those numbers in between, every number between negative 4 and 4 will satisfy this relationship. So therefore, those numbers are solutions to this inequality. So now I'm going to look at this next one. I notice 10 minus 4 is a positive 6. 10 plus 4 is a positive 14. This is a positive, and then this is a no region. So now, what's my answer to this? Well, my answer to this is then all the numbers that are included. Remember, that's a bracket, and this is a bracket. Okay, so in interval notation, it would be negative 4 to 4, and the brackets mean the endpoints are included. Okay, so if I would set this in set notation, I would say the solution for this problem is the set of all x's such that negative 4 is less than or equal to x is less than or equal to 4. And then I would put my right brace in, and that's how I would answer it with set notation. Okay, so the key is here, let's review this. 1, find your key values where possible by finding zeros on the left side after you've solved it for 0 on one side. Next, examine the fact that if this is an inequality with an equal, find out what values of x allow you to use the zero product property, and then select these points as solutions and do that first thing. Then delineate, after you write down your key values, delineate your work zones with dribble marks, and then pick a test value. Once you've picked the test value, then go ahead and evaluate that test value by doing sign analysis. We call this kind of a sign chart. We will use this in calculus extensively. And then from there we have a conclusion on whether or not this number, which is positive or negative, will meet the conditions of the inequality. Okay, and that's pretty much it. So let's do one more. Okay, we're going to now do problem number 16, which is x minus 3, quantity squared is greater than or equal to 1. Greater than or equal to 1. Our first step is, let's get everything on one side. That means put 0 on one side. So I could see this as x minus 3, quantity squared, minus 1 is less than or equal to 0. Now, we could use a graphing calculator, and we could make this an equation, a y equals, and see wherever this is above the line. And you could do it that way. Okay, I could rough it in like this. I could easily rough the idea in. Here, we notice that I'm going to have it shifted to the right 3 and down 1. So there's a vertex here. And I know that if I go ahead and see this, because A is positive, this is what this parabola is going to look like. Okay, now If we could find these zeros here and here, everywhere where this output of this graph is greater than or equal to 0, we could see that this is going to be our solution. All these numbers here are going to be a solution, and all these numbers here are going to be a solution. The numbers there wouldn't be. But let's go systematically and see how we're supposed to do that. Let's expand this and see whether or not we could put it in zero factored form. So I'm going to rewrite this as x squared minus 6x plus 9 minus 1 is greater than or equal to 0. So by combining the 9 and the negative 1, I see that this is 8. So I know that x squared minus 6x plus 8 is the same as x minus 4 times x minus 2 is less than or equal to 0. So we saw what this looks like graphically, and it turns out, in fact, these are the values here that we're looking for. This is 2, and this is 4. So let's go ahead and put together our sign chart. Okay, the first thing we're going to do is put our number line in. There's our number line. Okay, next thing is I'm going to put in my key values. Okay, so our key values are going to be 2, and the other key value is going to be 4. Now I'm going to go ahead and delineate my work zone under the 2 and under the 4. Now I'm going to go ahead and decide on what my test values are. My test value here, 0 is a good test value because it's left at 2 and it's easy to do the arithmetic with. I think 3 would be a good test value right in between. And then I like 10, as I've mentioned before. So I'm going to go ahead now and do sign analysis. Okay, so let's do sign analysis. So I'm going to Joop my two factors. And I could set up my Joop for the whole problem at one time. Once I'm in the habit of it, I'll just do all three. Go back here, plug in 0. Negative, negative, positive. Okay, now my conclusion. My conclusion is that a positive number is greater than or equal to 0. Oh, I did this again. I forgot to move and do the 2 and the 4 first. There is an equal sign. So I have to beat myself up and put those dots in there. Okay, I made a mistake. I should have done that first. Okay, so let's remember the next video. See if we figure how many videos can I go through where I keep doing this wrong, where I don't do that first. That's what I should be doing first. Because if I don't see, next example we're going to take and make sure we don't forget to do that, okay? I keep saying I'm going to forget to do it, and I probably will, but no, I'm not going to forget to do it. Okay, so our conclusion, positive, that's yes. So we're excited, we're elated, we have an answer, yes, and now I'm going to go ahead and shade my chart. Notice it goes all the way to negative infinity, all the way. So then I can see, now I'm going to start to discover something. You notice this is plus. Now let's look at the 0 here. The 0 is x minus 2. Notice it has an odd multiplicity. If it has an odd multiplicity, I'm going to start to discover that every time this 0 has an odd multiplicity, I really don't think we're going to stay the same. We're not going to go yes, yes. We're going to toggle. We're going to go yes to no. I predict this is going to be a no because the multiplicity of this 0 here is odd. Let's see if I'm right. Okay, we put in 3, negative 1, and positive 1. It's a negative. No. And then finally, I look at the multiplicity of the 4. I see it's odd. I suspect my clue is it's going to toggle like a light switch. It's going to go yes, no, because that was an odd multiplicity. And now it's going to go no, yes, because it's an odd multiplicity. Let's see if, as we do more problems, see if that's a telltale sign. So here's a positive, it's a positive, and we say yes. Okay, so once we get yes, we go ahead and we put the answer in there, and there we have a couple examples. And now let's write our final answer. So the solution to this problem now is, let's overlay this. The bracket's going to go this way. It's included. The bracket's going to go this way. It's included. So I'll write my answer negative infinity with an open interval symbol up to 2 closed interval union closed interval 4 to infinity open interval. So there's our answer. Hopefully you watch these two examples. We'll come back and do a couple more.